So we stopped with the introduction of this notion of a sufficient condition versus a necessary condition. Although this is not mentioned, if my memory serves me right, in this chapter on the conditional, it's good to know, I mean, to sort of, I think, sort things out. If we remember the basic rule that in a conditional of this form, if P then Q, then our antecedent P is the sufficient condition for our consequent Q, and our consequent Q is the necessary condition for our antecedent P. Now that may seem a little confusing right now, so let's work it out. We say that if P then Q. So what that means is that if we know that P is true, that is sufficient in and of itself to also know that Q is true. Right? That is, that P is a sufficient condition for Q. So you may ask, well, okay, if P then Q, not P, so why don't we say not Q? Well, think about it. All we've said is that if P is true, then that guarantees that Q is true as well. It is sufficient in and of itself to guarantee that Q is true. We have not said that P must be true for Q to be true. So if we think about that different wording, we can say if P then Q. That is something very different from saying if you look at that logically, think about the logic of those statements, they're very different statements. If P is true, then that's sufficient grounds for us to say that Q is true. But we have not said that P must be true in order for Q to be true. If we go back to our example up here, if the sun is down, antecedent, then it is dark, consequent. What we've asserted there is that if we know that the sun is down, then we also know that it's dark. But we have not asserted that the sun must be down in order for it to be dark. It could be dark for other reasons than the sun being down. We know that if the sun is down, then it's dark. But we don't assert that the sun must be down in order for it to be dark. Maybe there's an eclipse. Maybe by it is dark, we mean it's dark in this windowless room with no light, right? Okay. So in the basic idea here is that in a conditional, the antecedent, and you get used to that, right? Can't spell it, but I can say it. The antecedent is the sufficient condition for the consequent. Okay? So P in if P then Q, then P is the sufficient condition for Q. And let's just say that what that means is, being a sufficient condition, is that if we know that it's true, then we know that whatever it's a condition for is true as well. The other half of that is that in a conditional of this form, if P then Q, then the consequent, in this case Q, is a necessary condition for the antecedent. What does it mean to be a necessary condition as opposed to a sufficient condition? Well, a necessary condition is a condition that must be true in order for something else to be true. So that if it's not true, then we know that that something else is not true. But it's not sufficient in itself to bring things about. Let's go back to our particular example up here again. If the sun is down, then it is dark. Now, in that conditional, it is dark is a necessary condition for the truth of the sun is down. Now, think about it. We said that if the sun is down, that guarantees that it's dark. But the sun being down is not a necessary condition for it being dark, because there's other reasons for it being dark. The sun could be up, and it could still be dark. Right? However, when we think about the consequent, it is dark. That is a necessary condition for the sun being down. What does that mean? That means that if it's not dark, then we know that the sun isn't down, right? Because if the sun is down, then it is dark. So if it's not dark, then the sun is not down. If we think about it just in terms of a logical schema, again, going back to our if P then Q, or if we spell it out, as I'm suggesting we do as often as we can, if P is true, then Q is true, and Q is not true, then we can conclude that P is not true. Because Q is a necessary condition for P. That is, whenever P is true, Q is true as well. So if Q is false, we know that P is not true. Q is a necessary condition for P. So if it's not the case that Q, if the consequent is false, then the antecedent must also be false. Again, looking at, if P then Q. If P is true, then Q is true. We'll say that Q is true. I just assert Q. We accept that if P is true, then Q is true. And Q is true. Does that mean that P is true? No, it is not. That's a sort of classic formal fallacy in logic called affirming the consequent. Simply because I affirm the consequent and say that Q is true, or my consequent Q is true, does not mean that P is true. I cannot, in fact, I can't assert anything about P. I don't know that P is false, but I don't know that it's true either. Why? Because Q is a necessary condition for P being true, but it is not a sufficient condition. This should work out if we go back again to our example here. If the sun is down, then it is dark. It is dark. Does that mean the sun is down? Certainly not. Remember, it could be an eclipse. It could be other reasons for it being dark. That is, the sun could be up and it could still be dark. So, the conditional, man, I mean, it is tricky, but you just have to work it out. And I said in the beginning of the course, that logic is a matter of being very careful about what statements say and what they do not say. That becomes very, very true when we come to the conditional. And one of the things that our author says in the beginning of this chapter is I think, very helpful. That the conditional, she says, and it is, right? The conditional is the heart of logic, because logic is about implication. It's about inference. It's about what follows from what. And if you think about, then you're asserting that Q follows from P. You're asserting that if we know that P is true, we also know that Q is true, which is the sort of, I don't know, maybe the most direct manifestation of inference. So the conditional is tricky, I think. It does consist of two propositions, our antecedent and our consequent, but it only says one thing. It doesn't assert that the consequent, that the antecedent is true. It does not assert that the consequent is true. It asserts that if the antecedent is true, then the consequent must be true. That's all that's being said there. And sort of working out the logic of the conditional can be a little confusing, but you just have to sort of think it through. And I hope that thinking in terms of necessary and sufficient conditions is helpful.